Hi there, my name is Aaron Lancherman. I'm a professor of electrical and computer engineering at Georgia Tech, and here I'm showing the schematic for the Model 525C audio compressor limiter by API, and I would like to understand how this circuit works. And so what I'm going to do here is essentially show you something that I often do with schematics, which is to pull out various pieces of it using, I was about to say Photoshop. Here I'm actually using the GIMP image manipulation software. And when I say pull out, I mean just delete and get rid of things to try to make it easier to follow what the actual important part of the circuit is. Not that powering your op amps isn't important, but that sort of thing is sort of infrastructure. It doesn't really help you understand the real guts of how the circuit is thinking. And I was going to do this to the schematic, as I often do with schematics I'm trying to understand, and thought I would just record myself while I do this. So this is not going to be anywhere nearly as refined as my main lectures. In fact, I'm not going to even edit out that cough. So you probably don't want to sit here and watch this, but in case you do, here it is, and I'll occasionally make noises while I'm doing it. The APIs in general, they, instead of using chip op amps off the shelf, they had their own discrete op amp, the 2520 bit of a module. It has a ground pin in addition to plus and minus power pins. Most chip op amps just have a plus or minus power. They don't really have a separate sense of ground. Okay, so I think up here was grounded. So what I should do is I should actually find a ground symbol. I'm going to borrow the chassis ground. Now, I'm not actually going to use it as a chassis ground. I'm just going to put down some places that need to be ground. I'm going to just plunk it down places to indicate where a ground is. So I have another screen that has the original schematic, the unedited one, and that way I can refer back. What I need to do is get rid of this line here, and then let's see what's coming out here. Okay, this actually connects here to a ground. Let me eliminate all of this. Like this is hooked to ground. All of this stuff is ground. Why do they want to make this so complicated? So what I'm going to do is I'm going to take this ground symbol here, this chassis ground, and I'm going to paste it here, and then I can drag it and put it there. Sure, we like that. Let me actually export as, and then I'll make this edited. There we go. Export as images JPEG. Actually, okay, sure, why not? It's probably not best to use JPEG for this sort of thing. Let's see. So notice what I'm doing is I'm taking out the ground and power wires going to the op amps. And in fact, I'm going to do this with a lot of the ground and the power. So this is drawn in kind of an earlier style where every connection is explicitly drawn on the schematic. Older schematics will tend to do that. I find that it makes things generally kind of just totally unreadable. Let's see, let's get rid of this wire. Let's get rid of this one. We'll basically assume that these power connections to the op amp are being made, and other places where we really need power or ground, we'll use an appropriate symbol. So here's power coming up through here. Okay, let's get rid of all of that. Let's see, what is this line coming up here? Okay, this looks like it was the thing that was setting up the power to the op amp for the negative rail. Let's get rid of that. Look at all of this. Okay, do we really need this going up here? This negative line? No, that's not negative. That's the positive rail voltage. So I'm going to kind of get rid of all of that through here. Right, we don't need any of that. It doesn't actually get used until we hit this point. Same thing for the negative power. Notice there's these diodes here going to the plus 15 and minus 15. That probably prevents damage to the equipment if you plug these things in backwards. So Don't know what diodes they're using here. If they're using silicon diodes, there's probably a 0.7 volt drop. So plus 15 of the circuit is probably really something like 14.2. Similarly, minus 15 is probably really minus 14.2 or 14. I can't do math. Minus 14.3 to 14.3, something like that. Now, if they're using Schottky diodes there, those probably have more like just a 0.3 volt drop. So that would go between like minus 14.7 up to 14.7 would be your supplies. But what I'm going to do is just use this minus 15 symbol, paste it. Okay. And okay, where did it go? It's coming over here. So like this node up here wants one. Right, so this is now, we just know that this, oh, let me flatten everything. Where did flatten go? Flatten image, there we go. All right, so there's a minus 15 here. And yeah, it's because all of this set in here is using, this is using PNP transistors. So if you're using NPNs, usually there will be a plus 15 to ground, but you sort of have to flip everything around in your head. Oh, I lost one of my minus 15s that I wanted. So I'm getting rid of that big line there because I really want to remind myself that the fact that this connects to here, or this connects to here, or any other minus 15, that's not really important in trying to understand what the circuit is doing. So we can get rid of these lines that are just kind of causing clutter. Flatten image. Okay. Clear that. Yes, this is tedious, but I find when I do this, I wind up with something that helps. It really helps me to understand what's going on. Now, a modern schematic would probably be already drawn in the kind of style I have over here. Wouldn't need to be doing this. But for some reason back in the day, they really insisted on doing this. Okay, so this is V minus. V minus here. Okay, I'm leave the rest of that here for now. This is ground coming into here. Let's see. Don't need this here now that we understand what's going on here. Oh, we'll come back to that point. All right, so we tidy that up a little bit. What's coming from here, this factory test? Is that just minus 15? What is that? Let me go back and check. Oh, no, it's an overlapping line. The factory test goes over to the right here. Do I want to leave in that factory test? Let's go ahead and leave it in for now. Sure. All right. Let me take this ground symbol and just try to clean up the logic of what's happening through here. So what I'm going to do is I'm going to get rid of this, get rid of all this, get rid of this, and paste in some grounds. So there's a ground here. Oh, let me actually move that up all the way. Right. Okay. So I've got a ground here. Stick it in something like that. Oh, that's just there now. Okay. Okay, fine. Let's do a copy, paste. This is going to be pasted. Oh, I need to do something where when I copy that, I should have the bit that's coming out the top. Ah, why didn't that work? Oh, do I need to keep flattening? Let's flatten. All right. If I knew what I was doing with layers, my life might be easier here, but I don't. So, okay, rectangle, grab this section, copy it, go to the general, paste it. Okay, there it pasted it in the middle. Paste it again. All right, let's flatten that. Clear out this stuff in between because it is not important. It's not important. Not important, not important, not important. You're not important either. Right? Okay. What is important is that this guy is going to ground somewhere. So let's put a ground here. Let's flatten that again. Here's the JFET. That's part of the gain control mechanism. So I'm going to get rid of these lines here. The end load, that's just hooked to ground. Let me just get rid of that. It doesn't really matter. Whatever's coming in from here, the signal's coming up here. That's where the signal's coming in. Whatever called in low, that's just hooked to this ground. So, okay, so we'll put a ground here. And we'll put a ground here. And let's see. What's the clearest way to make this make any sense? Okay, so the capacitor here, again, I'm trying to uncover the logic behind the circuit. Put this ground here. There we go. Let's see. So all of these lines are grounds. This is probably showing that it's using some shield. I'm guessing that this is shielded cable through here. That's why that's hooked to ground. It's not actually that terribly important in understanding the logic of the circuit. Let's see. So these capacitors are hooked to grounds in various spots. Clear this out, clear this out, clear this out. Don't really need this to understand what's going on with the circuit. So we'll get rid of that. Okay, so these two capacitors here connect the positive and negative supply after these protection diodes to ground. So these two are actually not that interesting. These are 10 microfarad caps that are just filtering power coming into the board. So let me actually just move these caps all together. So I'm going to move this one over here. And then I'll take this capacitor here. Let me chop that out there. And we'll move it over here. And what do we really have going on here? All right, so I'm going to copy this guy. Okay, there we go. So I'll put something there, and I'll put another one over here. And then maybe I'll even copy a bit of line. Something like that. It's ridiculous. If I pretend that these diodes aren't here, right, then oh, I should be, okay, I see what's going on now. Let's see, wait a minute. Okay, so, wait, which one was which? Okay, I need to go back and look at the original. So C16, I like that. So, right, ground is the, okay, the ground for this one, C15 in the original schematic hooks to the negative supply. So I really should do it like this. This should go up here. This is awkward. And then the minus 15 here should go here. Let's see. Grab this guy here. Yeah. All right. Now, does this make sense as the bypass procedures? So we have a positive voltage compared to ground on the positive side of this cap, and that looks like it's appropriate for the original C16 on the original schematic. And here I have the more positive voltage, which is ground, relative to minus 15. That's the positive. Okay. And again, this is all sort of assuming that I'm assuming that no voltage is dropping across of here if I'm using that notation, but let's just go with it. All right. So I don't need this anymore, and I don't need this. Okay. Okay, so let's actually try to tease out what's going on here. This plus 15 is, oh. Actually, before I tackle that a little bit more, actually let me pull out some color. It's red. What about red? I really want to indicate one of the most important signals that we have. And let us select a smaller brush here. There should be a pencil tool, right? Paint tools, pencil. So that pencil tool, let's decrease the size, shall we? Okay, that's a little too fine. Probably should mention I actually don't know this program very well. Okay, so I'm going to, can I draw an, oh, it's in grayscale. Let's change the mode to RGB. What I want to draw now is this path that goes up to the gate of this JFET, because that is the main gain control element. So I'll draw this going down through here. Like through this, it doesn't actually intersect any of these cross wires, which is the thing that I want to emphasize here. All right, and then it goes over here. And again, it's not actually intersecting these. It's whatever these are going up and down. So let's see, this goes to two places. Or you could say it's coming from two places. I'm not sure how you'd want to phrase that. Let's see. Let's see if I can do that better. There's probably a click here to here line tool. More of a painting program than a drafting kind of program. All right, so, and it doesn't connect here. We can get rid of this. This is just a ground wire going up. Just, why can't you use a ground symbol, folks? Just make this whole thing a whole lot easier. I'll come back to that. Okay, remember all of this stuff down here is ground. In fact, let me go ahead and grab a ground. Do. You get a ground. And you get a ground. And you get a ground. You get one. You get one. Meter calibration. That's very exciting. Here. Oh. Okay, stay there for a second. This meter cal, I'm actually going to indicate that. I'll just stick it here for a second. Let's see. Well, actually, I can put it here, right? Let's put it there. And we've got this release time override, right? That's this potentiometer here. There we go. If I've somehow managed to confuse myself, which happens a lot. Let me put it here like that to indicate what's going on. Okay, something like that. All of this stuff here doesn't need to be here. Don't need all of this either. And yes, I could just have this big line here, but it makes me happy to see individual ground symbols. It helps me understand the underlying logic of the circuit. Let's see. That's a bit of a mess looking, but whatever. All right. And, okay, so this goes to a ground over here. And then this guy goes to a ground here. Okay, so take this part. Let's see, I was trying to get a good sense of what's happening over here. So this is grounded. So these two capacitors both go to a ground. And what I'll do is strip that. So if this was something I was trying to do for a more professional looking YouTube video, I would edit much of this out. But basically this is a thing I was going to do, and I invited you to join me while I do this boring thing. Now let's think about the logic of what this is doing. I would really like to just redraw this whole thing. I think this is the way this whole thing is drawn is unnecessarily complicated. But the main thing is up here we have this going to a plus 15. Let me put it here. There we go. Down here we have the minus 15, right? Which kind of hits this point. Okay, let me do that. I really want to move this whole line over. I hit the wrong tool. Wow, that is definitely not what I meant to do. That may make what I'm doing here easier. Let's see. I'm going to move this up here. No, what was going on here? Well, that was all going to ground. Oh, here's a ground. Let me grab that. And stick that. Maybe I'll stick that here. And I'll even put another one here. Because I would really like to think about these as separate things. All right. Do. Oh, wait, no, this crosses through. That's the thing is, as I'm doing this, I have to make sure that I'm looking for junction dots and not taking cross points that suddenly look like T-junctions and assuming that they're a junction, because they're not. So all of this stuff, get rid of all that there. Okay, so there is, looking back at the original schematic to double check, there's a minus 15 that goes to the collector here. All right, so minus 15. So if I select something and then copy it and then click anywhere, then when I paste it, it appears in the middle. But if I select something like this, hit Command C or Cloverleaf C, I'm on a Mac, and without clicking anywhere else first, I hit paste, then the pasted version appears in that spot. All right, so in terms of understanding the logic of what's going on in the circuit, I can get rid of this. Okay, I have to remind myself what I'm using as plus or minus 15 throughout the rest of the schematic is really what's on the other side of these diodes. Now, with all of this stuff cleared out, it's a bit easier to see what's going on here. Oh, let's see, what's happening with the R3? Oh, R3, this connects to a ground. Let me put that in here. Grab a ground. And it looks like, okay, so if I, let me clean this up a bit. I'll put this one here. If I paste again, then it will start from that point. So that was convenient. Okay, I think I'm getting the hang of that. So this is not a junction here. So we have the input going here. There's a test point here. Let's look for other places. Ah, okay, the center tap of this transformer, this is grounded, right? I don't even really need this here, though. I could even, what I'm going to do is I'm going to take this C, let's zoom in. Zoom, 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 zoom. Okay, this C14.1, I want to make some space, so I'm going to move this over here. The C13.1, I want to make some space, so I'm going to move that over there. And when I do that, now that I've made some space, I can make it clear that what we're doing is we're taking this, I have enough space here, I can do this. I just distracted myself. Let's see, we'll put it here. All right. So that's showing that the center tap of that side of the transformer is grounded. All right, then we can do this. Oh, so this is really just, let me just do this. I'm going to take a wire, stick it here, and then just get rid of this altogether. So that potentiometer, the release time, what do I call this? Release time override potentiometer, that is just acting as a variable resistor, this 47K. So it can be anywhere between 0 and 47K. On the other hand, this meter calibration, this is actually acting as a voltage divider. All right. Let's see. Kind of like the way that I like the way this is shaping up. Let me clear out all of this junk here. Make this look prettier. All right. Don't need any of this now, or whatever this was doing down here. Let's see. Okay, so all of the uses of ground down here have been called out. We're only using negative supply on the bottom part of the schematic. This is part of the side chain. At some point, I got rid of some lines here, which I didn't really want to get rid of. I probably accidentally pasted ground or something on top of it. So I'm going to grab this and scoosh it up there to reconnect those. Let's see. Okay, so this isn't actually a wire. Is there something on the schematic that says all about all of that? Switch 1, A, B, C are mechanically interlocked. 2, 3, and 4 are alt action. What does that mean? Okay, so when I looked up mechanical interlock, I saw a bunch of stuff about circuit breakers and things that you can use to hook your house power to your generator to make sure that when you flip over to using the generator doesn't like try to feed power back to the power company. And I found this picture of a old vintage API. So if you look at mode, there's C, L, and off, presumably for compression mode, limiting mode, and off mode. Now, the newer version of it, I guess you could call this a modern reissue that API makes, has a CL off for bypass. Because in the original off mode, the signal is still going through a bunch of the circuitry. And the bypass mode in the new one is what guitar players would call true bypass. No. Oh, sorry. 3:29 in the morning. I'm just having so much fun. I could see how you might want to have this off mode as a mode where you're just running the signal through the transformers because people get excited about that nowadays. Even if you're not actually doing any compression or whatever, people like transformers, I guess. Whatever. So the interlock mechanism, I think, is the fact that the limit, the compressor, the off mode, there's no, this is, I guess, an old schematic, so there's no bypass mode shown here. The mode switch, I think by the interlock, what they mean is that you click a button and then either this one activates this one or these two are gang together, these two activate. But you can't press more than one button at a time. So I think that's what's going on. So what I'm going to do is so I don't wind up thinking that this is a wire, I'm actually going to take this out. This stuff through here. All right. Okay. And I'm just going to say, this is mode. Look at the mode. All right. Flatten image. Okay, let's see what else was happening in here. Oh, here's the meter. Okay, so knowing what's happening in the meter, that's good. Signal comes in. Let me move this ground over here. And then I'll put a wire, move the wire over. So here's some wire connecting that. All right. Because, let me double check this. All of this stuff going through here, that was ground. And let me double check to make sure what I'm saying is correct. Yeah, so let's see. What's up with this in... Actually, here's the better way to think about it. Let me get rid of this. I'm going to kind of scoosh this down here a bit. I don't really need any of this here. Let's see, so the top, how should I describe what's going on? Okay, so the bottom of the out pot here is a ground, this thing that we called out. Okay, so I'm moving this over here a bit. I don't know why I did that. Let's see. Okay, let me grab a ground, put that here. All right, so that's, let me put one here. It's probably a better way to draw that. All right, flatten the image there. This is starting to make a bit more sense. Let's see. For the FET here, let me actually take this ground and move it up here like that to make things be a little more obvious of what's going on there. DS1, DS2, are these lamps that go off? Oh, these are indicative of whether you have something activated or not. Okay, offline I did some digging around, and it does look like the lights are in the meter. So it looks like this is set up that when you're not in off mode, the lights here in the meter light up, but when you are in off mode, they don't light up. And okay, so that's not terribly surprising or interesting. Let's take a look here about what else maps to what. DS, this is some sort of de-esser control, so we'll look at this probably in another video. This is including or not including some filtering operation in the side chain. The modes are, you can't see it in here, but there's C, L is 20:1, C is 2:1, and that's indicated by the compress or the limit switches here. You're supposed to only push in one of these at a time, although it looks like there's people who do push in both of these at a time. The release is set by these two buttons, and you can push in or not either of these. So there's 4 different release times you can pick by either having neither of these pressed in, one of them pressed in, but not the other, and vice versa, or both of them pressed in. So those are over here. The in and out knobs you see up here, those correspond to the in and out potentiometers. Those correspond to the in and out potentiometers there. And I think in the next video, we'll actually go through the simplified schematic and talk about the different sections. Okay, actually, before I call it a night, I do want to color this in. So this is going to be the red line here that's coming out of the detection circuitry in here. That's what drives the gate of the JFET that controls the amount of gain reduction we're going to get. Now there's another sort of parallel line coming out here. Let me use a different color. I guess let's try green. Coming out this direction. It's basically giving the same thing. I think probably just with the sign flipped. I'll need to think about that. Anyway, it goes through here. I'm just going to go ahead and use green. And what we'll do is say we need to recognize that some other stuff is happening to it in the meantime. Like the fact that there's this diode and resistor here, all of that stuff is part of this. And it comes up here. And it goes through here to the meter. Okay, so one of these lines is going to the metering, and the other is actually going to control the actual gain reduction by putting a different voltage on the gate of the JFET.